So yes, we do have ourselves another thunderstorm risk for much of the Northeast. So if you live in these regions, this is applicable to you. The Northeast, also neighboring Eastern Ontario, Southern Quebec. This is for September 4th, 2025. There's also a chance for strong to severe thunderstorms. So why don't we just take a look at the environment very quickly and determine why this risk exists and what hazards to expect. So stick with me to the end of this video and I'll explain exactly what to expect in terms of hazards and the overall timing and when this event is expected to end. Okay, so this is a surface chart that shows us various frontal boundaries, typically warm fronts, like these red semicircle lines, and then these cold fronts, so these blue spiky lines. So this cold front will be the principal driver for our thunderstorms tomorrow across the Northeast, much of the Northeast. This is for early evening of September 4th. So this will be one of the principal drivers in addition to a shortwave trough. Okay, so just a quick check on how strong our cold front is. So we can do this based on some evaluation of surface moisture convergence. That's what this map is showing. So the brighter colors essentially mean higher amounts of convergence. So let's go a few time steps ahead. So right now we're in the afternoon, so it's 2 p.m. 2 p.m. of September 4th, and you're seeing these brighter colors starting to appear, which means our cold front is strengthening. The amount of convergence is also strengthening as a result. Okay, so now focusing on the amount of lift that's actually occurring at mid-altitudes. So this is the 500 millibar vertical velocity profile. It's actually measured in microbars per second. So really what we're looking for are these bright, intensely looking colors. So these yellows especially to reds and purples. And you can actually see that taking place because we have a potent shortwave trough that's unfolding in southern Ontario. So as we go further, let's go a few time steps ahead, and you're actually seeing this feature starting to intensify as it moves to the east and northeast. So we're seeing large amounts of lift actually appearing as it moves off into Eastern Ontario, Southern Quebec. So this is going to create widespread convection, I think, and among these, I think at least scattered thunderstorm development. Okay, so here's a check on our mid-level lapse rates. As you can see, not really much going on across the Northeast, Eastern Ontario, South Quebec. We have very modest lapse rates, typically about 4 to 5.5 degrees Celsius per kilometer. And let's go one time step ahead a couple of times. I do see a little bit of a maximum starting to appear, where these little maxima, subtle maxima, taking place in time for the evening, where we get a boost to about 6 degrees Celsius per kilometer. Same for Eastern Ontario. So this could actually help to amplify instability in a subtle fashion towards the late afternoon to evening period. The sun is getting through later in the morning, or most of the morning into the afternoon. So we do expect large amounts of steepening, and we do actually see just that. So by late morning, you do see these rather steep rates taking place. So this is like 7 to 8.5, even 9 degrees Celsius per kilometer in some areas. And as we go forward, yes, you do see even more steepening. This is 2 p.m. in the afternoon. Rates of even up to as much as 9.5 degrees per kilometer Celsius per kilometer is actually overspraying the region. So yes, we do have a lot of steepening. And just going one more time step, that stays with us even up to 5 p.m. before that cirrus cloud cover starts to appear, as you can see in the slot in Eastern Ontario. That's why you're seeing these lower rates, because there's a lot of cloud cover and rainfall. Okay, so doing a quick check on how much humidity is in the air in our warm sector for tomorrow. So this is pre-dawn September 4th, but as you can see, as we go further into the day, nothing that much different. So the air is still restricted with humidity. It's been a continuation of what we've been seeing all August and up to this point. So really not that humid, nothing crazy. The dew point is able to reach about 57, 58 Fahrenheit. That's close to 15 degrees Celsius, which is about moderate humidity. And notice this stretch of hues of blue. Yeah, so notice this blue, these shades of blue starting to move from west to east, or southwest to northeast. So this is not actually caused by warm air advection so much, but it is induced by rain-cooled air. So as the rain starts to fall, it brings the air closer to saturation, and it does humidify the air that way. So at that point, we do have a maximum of about 64, even up to 66 Fahrenheit. So that's about 18, 19 Celsius. So that will pull the humidity up in time for 8 p.m. tomorrow, and going into later in the evening as well. Okay, so a quick check on how much instability is actually unfolding for September 4th. So this is the amount of CAPE, convective available potential energy. It's a representation of instability. So we're looking for these brighter colors, which represent higher amounts of CAPE. So let's go into September 4th. So we're mostly interested in the afternoons. So let's zoom in right into the afternoon period. So this is now 5 p.m. on September 4th, and we're seeing not a great deal of instability, which is to be expected given the environment that I showed previously in terms of mid-level lapse rates or the lack thereof, and limited surface moisture. CAPE of as much as 500 joules per kilogram. We have some pockets of up to 1500 joules per kilogram. That's actually possible farther north as well. I think there might be a bit of bias here, but I think CAPE values are generally going to reach 1000 joules per kilogram at a minimum, including in Eastern Ontario to Southern Quebec. Okay, so here's a sounding profile for the west end of Montreal. So this is our reference point for the risk area in general. So this is 5 p.m. September 4th, and just a couple of things, maybe even three things here based on what I'm seeing. Wind barbs. So these wind barbs are pointing mostly in a unidirectional fashion above the boundary layer in a south-southwest fashion, right? But below the boundary layer, we have a veering component in which the winds are pointing south-southeasterly before they actually turn to the south-southwest by the time they reach the upper portions of the boundary layer. So this suggests to me at least some convective organization is able to appear tomorrow, September 4th, across eastern Ontario, southern Quebec, and portions of New York. But another factor that I'd like to mention is the potential for strong winds with some of these thunderstorms. This is because we have a strong south-southwest flow at 500 millibars, as you can see from these wind barbs. When you see those flags, that represents some heightened wind speeds. And at the same time, some other elements that lend support to that idea altogether is this dry air component. So you can see this green line represents how humidity is changing with increasing altitude, and you can see a rapid decrease. You do see a drying actually appearing, and that will help to fuel the possibility for locally strong winds. And at the same time, we have a fairly cold 500 millibar temperature, approximately minus 11 to minus 12. As shown here. So this will not only improve, in addition to the previous elements, the chance for locally strong winds, but it will also increase the chance for small hail with some of these thunderstorms. Okay, so based on what I showed previously, I do think thunderstorms will be developing within this broad zone. So this is where lift tends to be maximized ahead of our cold front. So you remember that cold front and also the shortwave trough that's joining forces with it. So the lift will be best in Eastern Ontario to Southern Quebec and much of New York, central New York particularly. So the thunderstorms will be mostly gathered in that zone by tomorrow early afternoon, I think. So these thunderstorms will also be moving quickly to the northeast. Remember our wind shear factor, the south-southwest wind shear fields will be guiding these thunderstorms pretty quickly to the north-northeast. So they will be moving fairly quickly, and they will be grouping together pretty fast as well. Now, I think the best chance for thunderstorms altogether will be mostly in this spot, mostly in eastern Ontario and central New York. I do think that as they move farther to the northeast towards southern Quebec, they will start to group more into the broader rainfall that is actually within the area as well. So this will be something to watch as they move northeast. So I do think the thunderstorms will diminish in number as they do move towards southern Quebec and eastern New York altogether. So it doesn't mean that the thunderstorms will just vanish. It just means that rainfall will be taking over more prominently as we go later into the afternoon into the evening. But the hazards will remain with the thunderstorms that do survive. In all cases, whether it's eastern Ontario or southern southwest Quebec, will be mostly the strong straight line winds with some of these thunderstorms and locally small hail. Lightning frequency, I don't think it's anything too crazy, but I will be willing to say up to moderate lightning altogether in this broad zone, especially in Eastern Ontario. I think there is a real chance to achieve moderate lightning frequencies. So that's pretty much the environment. This is mostly an afternoon to evening period. Evening, I think, is most important farther east into southern Quebec and much of eastern New York. I do think the tornado risk will be most important within this broad domain, if anything, before the thunderstorms really have a chance to consolidate. So this will be something to watch as well early in the forecast period. So again, it's mostly a damaging straight line wind hazard that I think will be occupying tomorrow's situation, but you can't rule out an isolated weak tornado in this zone. And I even include this part of New York as well. So that will be something to watch. So thank you very much for your attention. Always appreciate it if you made it this far. So if you found this video informative, if you found it insightful, that was able to provide further details of interest, feel free to subscribe to not miss out on upcoming forecast videos for thunderstorms, not just for the Northeast, but it could be other regions by request. If any of you are interested in that, that could be done as well. And if there's anything else, I will post it in the comments below.